Fair is a fantastic word that people are now using to describe data. The problem with it is that they've stepped away from recognising that it's an acronym and is actually made up of 4 terms. Actually, fair is findability, accessibility, interoperability and reusability. We need to move beyond this conversation of the idea that we're creating fair data and recognise that we're creating different parameters of that data. So we increase its findability, we increase its accessibility, we increase its interoperability, we increase its reusability, and it's the bringing of those together that is the really important thing. We need to move beyond this idea of things are fair and think about them in terms of its component pieces. The big challenge that we're all facing with respect to fair is that our legacy processes for capturing data are based around verticals supporting a process. So that could be the design of a molecule, it could be a study, it could be a submission. All of these are processes that we have automated and we capture data to support the progression of that process. What we're all wanting to do now is pivot and ask questions that are cut across those processes. Now, the data was captured and designed for support within that process, and as soon as we move outside of that context, that's where we have the trouble joining it together. We've got to be able to make data that's findable based on metadata from one process and another process. So it's connecting that together, that's the interoperability, and then we've got to be able to access that data, and when we can access it, provision it in a way that is reusable, and we understand the consent that we can reuse that data. So data centricity is another one of these major movements in the way that we approach data. When we talk about data centricity, we're talking about moving away from that traditional applicational approach to building or using our data. So I spoke previously about processes where we have applications that support those processes. If we continue to build application-centric world, we end up with the information being focused around the application, the process that it's supporting. By moving to data centricity, we align our data in a common form in the first place and then have our applications surface that data back into the support in the process. So it really is turning the world on its head and making our data the primary thing rather than the application. And that transformation is what we're doing when we drive these data together into a knowledge graph, as an example. So knowledge graphs are absolutely central to what we're attempting to achieve. The need to combine data in this data-centric fashion is enabled by knowledge graphs. The question really comes down to what is a knowledge graph, or how do we use knowledge graphs? And I see 2 use cases. One, which is to help people navigate and explore information space. I often refer to this as a knowledge map. And the other one is for driving the sort of insights and the business intelligence, the machine learning and the AI type of activity, which is really an analytical type behaviour. And I would describe this as an analytical knowledge graph. Now, a knowledge map tends to be shallow and broad. It's about connecting information together, providing integration, whereas an analytical knowledge graph tends to be narrow and deep. It's about driving analytics into a domain space. So what are we doing? We're really using knowledge graphs to integrate data and let people explore and analyse, and then we can look to extract data, export it from, say, that integration knowledge graph, the knowledge map, into an analytics environment to allow people to do deep analysis, where they might use an analytical knowledge graph to solve their problems there.